Okay, welcome to Weld Symbols Part 2. If you are here watching this one, that means either you got something out of the first one or your instructor's making you watch the second part. So either way is fine with me. Before you move on, if you haven't already, I really want you to do the practice weld symbol worksheet that's included in the drive for you, because you've got all the information you need, and it's a great way to review just the basics. This video is going to talk a little bit more about a little bit more advanced things about how we talk about indicating more information. But if you don't understand the basic weld symbols, then it's going to be difficult to move on. So do the practice one first and then move on. So other things that we're going to be able to take a look at. We're going to take a look at specifying the root opening for a weld symbol. And of course, hopefully you know that that means that it's the opening at the closest part, usually at the bottom of the weld, although if we're doing something else, it could be the top part. But the root opening is going to be a number that's shown within the weld symbol. So in this case, it's the 1/8 inch. That's a square groove weld. And when we finish it, it's going to have an 1/8 of an inch gap in there. We're going to weld on both sides because the symbol is on both sides of the line. But we're going to, obviously, the 1/8 inch gap is going to be the same with both of them. Sometimes, every ones that I will use will be in fractions. I'm told that like hay and forage, they use metric. So that could be in millimeters. And so you'll see those in that case also. Let's take a look at this one. You got 3 different numbers there. Which one of those is the root opening? Is it the 1/4 inch, 3/8, or 1/8 inch? Well, if you listened, obviously it's going to be, well, always mostly a fraction, and it's always going to be in the weld symbol itself. So in this case, it is the 1/8 inch. Move myself over here. If if it is not indicated, and that should be an important thing that you put on your notes, then it's going to be a 0. And so sometimes we don't, we're not going to specify. If the engineer doesn't want there to be any kind of a root gap, then they'll just leave it, and you should know that that would end up being a 0 at that point. Okay, so that's one thing we can show within the weld symbol. The other thing is the groove angle. So for definition, those need to go into your blanks there. It's the included angle or the total angle, and it's shown above or kind of within the basic weld symbol itself. So the example we have here is a 60-degree angle, or we're going to have a V groove. It's below the line, so it's arrow side. The arrow is pointing to the top, so this would be correct in placing it on the top. And we're going to take and we're going to bevel both pieces of metal, and with a track torch, a grinder, or a plasma torch, or something like that, and put a 60-degree bevel in there, 60-degree included angle. So we're going to put a 30-degree angle on both pieces. That adds up to 60. And so go ahead and sketch it on your notes page. There's a place there and it says sketch these. So go ahead and show that. Hopefully that'll help you when you come back to having to do some problems with it, okay? We're gonna move on to the second part. Oh yeah, this isn't in your notes, but groove angle and root opening can be shown in both. So we have here we have a pretty thick piece of metal probably that we're going to put a V groove on both sides, and we're gonna have an 1/8 inch in the middle, and we're gonna have a 60-degree opening. We would assume that would be on the both sides, but I have seen them where you would indicate a different one. But if that's what it would be on this one, I would put a 60-degree bevel on both sides halfway through. So now this is the one that's on the bottom on the right hand side of your notes. Go ahead and take a minute and sketch what this one would look like. Where would it be beveled, top or bottom, and what would the angle be? So pause this if you need to and sketch that in real quick. And I will show you what it should look like. We'll have a 40-degree angle. The arrow is correctly pointing to the right-hand side, so that would be the side that we would bevel. We always want to bevel the side that the arrow is pointing toward. That's what the engineer would want. All right, on to your next page. Should be a second page of notes. Contour symbols, we maybe want to indicate a certain shape of a weld that is finished. And so again, you want to sketch these in that space below where it says flush. Flush, another way of saying it is just flat. We want to get it flat, and so that we can weld it to where it's pretty well flat. We would probably, to get it perfectly flat, obviously we would need to grind it. There are certain situations where we would want a bit of a convex feed, so that would be indicated by that enlarged piece there, or concave, where it would be dished down into the piece, caving in. And again, if you do turn up your heat a little bit, or if you run it in a vertical plane, again, get those sketched real quick and pause if you need to finish sketching them, because I'm going to move on. Finish symbols. Those are letters there that indicate how you would go about finishing the weld when you're done with it. So we're chipping, if we're using a shielded metal arc welding situation, I want to grind it, especially if I'm going to grind it flat. A rolling operation would be a way to stress relieve and also maybe put a bevel on it. But if we want to machine it, hammering, to me, I would think you would use like a ball peen hammer, and that would be more of a stress relieving piece. So not one that I see very common. Chipping and grinding, I think, would be the two most common. But again, you might write that down. You'll need to know this, and I would hope that you could refer to your notes when we move on through that. And then we can use them in conjunction. Again, this isn't in your notes, but just something to look at. We could show that we bunt on a flat on the bevel face. And notice how these are situated too. When we show them, they should be on the face of the weld. So on a fillet weld, your contour symbols go on that angled piece because that's where the weld face would be. And so we could indicate them on both sides. This one would be other side. This one on the left-hand side on B would be the arrow side. So just a little graphic to show what those would look like. All right, let's talk about the size of a weld. It's really, really important that this is different if we have a fillet weld, which again is a 90-degree, or some kind of a groove weld where we are beveling or putting two pieces of metal together that we're butting up. If we're doing a fillet weld, that's going to refer to the length of the two different sides. Okay, so the length of the sides is going to end up being the fillet weld. So for example, if I have a 3/16 here to the left, that means that this vertical edge and the horizontal edge are both going to be 3/16 of an inch. This one's a little bit different. The 5/16 would indicate both that it is coming out and up 5/16. It is not the face of the weld. And so if you have a weld gauge to size these, that would very much, that's an easy way to indicate what that size should be. And as you get into more advanced welding skills or competitions, they'll let you take a look at, or you'll need to be able to get the right size of a weld. 5/16 is a pretty good size weld. And important to note, very important to note, the size is always to the left of the symbol. I already have that there on your notes, but I would sure put a star beside that or circle it. I always have students that come back and say, where do I indicate the size? Well, I told you to start on your notes, so I'm telling you, put a star beside that. You've got to know that. All right, here's where it gets tricky. If only one number is given, which is normally the case, the length of both sides is the same. That's almost always what you see. So just like that 1 5/16, it's going to be the same on both sides. So the vertical leg and the horizontal leg are the 5/16 of an inch. But if we give two numbers, then the shape of the weld symbol shows the length of both sides. Please underline the word shape, and hopefully we'll refer back to it, the shape of the weld symbol. So let's take a look. This one doesn't do a really good job of showing that, unfortunately. I should have a better graphic. But if I have two numbers, 1/4 or 3/8, which one's bigger? The 3/8 of an inch is a bigger one. And so we would draw this symbol to where that line would extend out a little bit more and be a little bit flatter. And so you should be able to look at the symbol itself and understand that that was going to come out a little bit further. There's a lot of reasons an engineer might want to do that, not just to make your life miserable. But this is how the weld would look if we were to finish that up. Again, we come out 3/4 of an inch, only up 1/4 of an inch. So not a big difference, but yet it would be significant if that's what the engineer wants. All right, now, groove welds, two pieces butted up together. When we talk about the size of a groove weld, it's not how big the weld is. Size means how far are we going to grind or cut the base metal. So it's the depth to which the base metal should be prepared. Either we're going to cut it, do a cutting operation with a plasma torch or a torch, or grinding it with a grinder, which can take a long, long time. So let's take a look at this one. We are showing a 60-degree included angle, but the left side, the 3/4 of an inch, that's a pretty thick piece of metal. But that means when we get done gouging this, that should be at least 3/4 of an inch into that piece of metal. Looks like that's going to be about a 1-inch thick piece of plate. This can take a lot of weld to fill that up. And that's what the engineer wants, is a 60-degree angle by the time we get done gouging it and getting that U-groove on there. Okay, so the size is different than it is for a fillet weld. It should also be written to the left of the symbol. Okay, so again, I believe that's something, yeah, fill in the word left on your notes there. And again, that's important to know that. So here's a couple of graphics, again, that indicate several things. It can be different. On the arrow side, we've got a 1/4 inch depth that we want to V-groove that out, whereas on the other side, we're going to go down 3/8 of an inch. And there's still a fair amount of material left in between there. Whereas on this one on the right, you've got the 3/8 of an inch. That's all the deeper we're going. We're not putting a weld on the other side, so apparently that's going to be strong enough for what they want to use that for. Now, this term of effective throat, I've got it highlighted in your notes, and I think you ought to put a star beside that. The effective throat means how much penetration do I need into that weld? Again, we're talking a groove weld. So if we're doing some kind of a weld for a bend test, we would need to have it melt all the way through. So penetration is how far does it melt into the weld, but the effective throat would indicate to us how much penetration we want. A really important thing to help you identify which is which, it's always going to be shown in parentheses, and you need to write that down, that it's going to be in the parentheses, or circle it. I guess it's on your notes. But that's another one that gets really confusing for people. But it's an easy one to find because it will be in the parentheses. I'll show you some examples here in just a minute. So for example, you got a 3/8, you got a 1/2 inch. Which one's your effective throat? It's a 1/2 inch. It's in parentheses. And another hint, it's always going to be deeper than what you're going to grind it. I'm not going to grind it a 1/2 inch and only fill a 3/8. I'm going to grind it down, or U-groove this one looks like, to 3/8, or actually they're Ving it, and then that's what the weld would melt on down in further. So they want a lot of heat, melt that down in. Okay. Another one that is going to be tricky that I catch a lot of people on, if it's not specified, the effective throat is, you would assume it's the entire thickness of the metal. And on the worksheets that I give, if you don't tell me that, you've missed that point. So make sure that you understand effective throat. If there's nothing there in parentheses and there's only one fraction there, the effective throat, the engineer or whoever's designing that wants you to make that melt all the way through the entire piece of the metal, like you would for a groove weld for a bend test or something like that. Okay, so hopefully we understand effective throat and the size. Size of fillet weld is different than the size of a groove weld. That's going to be challenging, I think, when you try to go back through it. Length of weld. Sometimes we don't have to weld the thing the whole length of the piece, but if we have the length of the weld, it's going to be given to the right of the weld symbol. Okay, so in this case, we have two numbers. The 1/4 of an inch would tell me that it's going to be up a 1/4 of an inch on the vertical leg and out a 1/4 inch on the horizontal leg. But that 6 means that we're only going to put a 6-inch weld there. So well, what would that look like? I guess you'd put it in the middle. There's some ways in which, engineers might tell you want to put it in the first half, but usually we're going to, we're going to weld the whole thing, or we're going to weld a piece, skip, and then we'll put another weld in, which are intermittent welds, which we'll talk about here in just a minute. Normally give that in inches as well, unless you're, again, using metric, and then you would use metric on all of it. So let's talk about that. We're not going to weld everything all the way. So if you turn your notes over, sometimes what we talk about is intermittent welds. And so we're going to specify, we're going to put a weld and we're going to skip, and we're going to put another weld and skip. A lot of times, ones I've done, they want to put them on the very edge and then fill in between. But however, again, that's something the engineer can specify. But that would be indicated here by this 2-4. Notice it's on the right-hand side of the symbol, and it's separated by a dash. So that means we're going to put a 2-inch weld every 4 inches. Okay, so that's what that's referring to. All right, so it's important to note, and I've got that there on your notes, that it's not the distance between each weld, but it's the distance from center to center. So another thing I would add, it's also the distance from the beginning of the first weld to the beginning of the next weld. If it's the distance from center to center, it's also the distance from beginning to beginning. When we lay out materials like that, we'll measure them out. We'll just measure out that distance and put a tack everywhere where we've got that spacing where we want it to go. So we'll put a little tack weld there. So in this case, I'd come over, looks like they came in 1 inch. I'd put a tack at 2 inches. I'd skip 4 inches, put another tack, skip 4 inches, put another tack, because every 4 inches. So if you think about it, that means there's 2 inches, then there's 2 inches in between. Another 2-inch weld and 2 inches in between is how they're wanting that to be welded. But we would, you just tack it up. We'll measure that if it's a long weld. Okay, so spacing is distant from center to center, or from the beginning to the beginning of the next weld is the easy way to set it up. Sometimes we don't want those welds to be directly across from each other, and so the simple way we show that on the weld symbol is that we just stagger them instead of being straight up and down. So these are the same thing. So if we're going to be offset, that means that they're supposed to be staggered. So let me show you what that looks like. If I'm looking down from a top view, this is a poor job of it, but I got a weld here, and then I got a weld there, so we're going to be on either side. So looking at the top view, we're staggering them so they're not across from each other. Okay. Sometimes we do want them to be directly on top, and so in that case, the weld symbols will be setting directly on top of the other one. And again, we would probably space them the same way. And again, poor job of drawing it, but we would do exactly opposite of each other, and probably would want to put a third weld in there. So that's probably not really realistic about how we do it. Okay, weld around, all around symbol. Sometimes we have a tubing or a square piece that's going to go all the way around. We just put that circle around the reference line and the arrow line, so it looks something like this. You might want to draw a quick arrow that's got that, but just that circle. That's real simple. That just means instead of saying I got to put this in 4 places, I'm just going to weld all the way around this piece of tubing. Okay, and I could also specify how big I want that weld to be and so forth. But see this one a fair number of times on stuff that I've done. Not one that I've ever seen is this field weld symbol. So this isn't real common for what I've been used to, but I would imagine if you put things together and build part of it in the shop and then ship it out to build on site, the field weld symbol would also go at that intersection of the reference line and the arrow line. And it would be a black triangle that would be filled in. So that makes it a lot different than the fillet weld symbol. Now, the last thing that we're going to look at in terms of information that can be piled into the weld symbol is this thing about the tail. The weld symbol tail can indicate a lot of things. And this is the one that I see the most commonly on the stuff that I've done. How many different places are we going to repeat this operation? And sometimes you got to kind of look really, really hard on the print. But instead of, they're putting this whole symbol in on 4 different places, the engineer's just going to say, here's where it's at, and here's where it's at. Now go find the other places that are the same kind of a piece and put this same weld in. So the weld symbol tail itself is going to give us information. You need to write these down. It can tell us the type of weld process, whether it's MIG, TIG, stick, or whatever. Tell us the number of places, which again is the most common one that I see. Maybe if you want to specify type of electrode, do you want it to be a 7018? Do you want it to be 6011? What does the engineer want? Or what kind of MIG wire does it want? And then what are the weld results? Does it have to pass a bend test? So what are the results that are required from that? Maybe you want it to fill flush so that it, again, I've seen that on weld symbols. So things that can go in the weld symbol tail. All right, let's practice a couple things real quickly. And you've got this illustration on your notes. So let's see what kind of information is shown there. Go ahead and pause this and see if you can put down what is the type of edge preparation that's indicated, what's the effective throat, size of weld, and what does that 40 degrees mean? And then if you want to sketch that final weld there, go ahead and do that. So pause this. I'm going to stop for about 5 seconds and then start going over that. So is the weld on top or the bottom? Is the type of edge preparation that we need? What size of weld do we have? Let's see if this comes in here the way I wanted it to. And sketch the final weld. All right, so here's our final weld. We're pointing it to the right. So this is a J groove. That's the type of edge preparation. It's a J groove. We've gouged one side, okay? The size of the weld, that weld is supposed to be 3/4 of an inch down into the metal. So that's all the further that gouge should be. Looks like there's another 1/8 of an inch left there. Maybe it's even a 1/4 inch. It would depend on the thickness of the metal. We don't care. What's the effective throat? Good question. Tricky question. Effective throat would be shown in parentheses. So since it's not shown in parentheses, it's the entire thickness of the weld, okay? That 40 degrees means that by the time we get done, we want that to be a 40-degree angle that's included in your weld, okay? All right, last one that's on your notes page anyway is this one. So again, same types of things. What's the type of edge preparation? Oops, wasn't supposed to show that. Let's back that up. And I'll stop there for a second. Have you sketched that? Now go ahead and sketch what that weld will look like. Is it and what side does it go on to? And what information does it tell you about? The type of finish, size of weld. Is there anything else that's there that you should be able to tell me based on that weld symbol? So again, I'll pause for 5 seconds and let you draw it. And stop me if you need to. All right, so obviously it's a V groove. Does the weld go on the top or bottom of the piece? Well, let's see. It's on the arrow side. Arrow's pointing to the top of the piece, so the V groove would be on the top piece of the metal. Okay, so since it's sitting on the arrow side. What's the size of weld? Well, not specified, so we're going to be the entire thickness of the metal by the time we get done. Okay, what type of finish operation is specified? You need to tell me 2 things. We're going to grind it, and when we get done grinding it, we want it to be to a flush type finish. So we're going to grind it flush. And so there's really 2 things that you need to tell me about that. Okay, and then what would the final sketch look like? Hopefully you've got that drawn. I guess I don't have that. But it would be a weld that would have a V groove sitting here at the bottom. And again, it will be flush with the top edge of it. All right, real quick, just a couple of things. We've already talked about this one a little bit. The arrow side always points to the edge that should be prepared. In this case, again, it's coming down to the right, so that would be the one that should be prepared. On this one, same thing, it would go to the right-hand side. So multiple symbols can be used sometimes to indicate different things about the weld itself. This one, instead of putting everything, stacking everything onto one line, we can use multiple lines. And this one would tell me that, first of all, I'm going to bevel that piece on the arrow side at 30 degrees. And then when I get done with the weld, I also want it to be a 1/2 inch weld up and a 1/2 inch out. And that I'm going to have it ground to a flush operation. It's going to go all the way around this piece of pipe. And both of these things are going to be done out in the weld in the field. So it's not going to be something that's done in the shop. A couple other things for you to look at real quickly. You know, this one here, just a basic fillet weld. Since this is on the arrow side, it would go on the right. It's out 3/8 and up 3/8 is the size of that weld. If we take a look at this one, that 2-5 means that we're going to put 2-inch welds every 5 inches. So every 5 inches, we're going to have another weld, and it's going to start at the end, and that's going to end up on that piece, finishing out right there correctly as well. And on this one, they have two different sizes of, or two different types of groove angles. A 45, since it's on the arrow side, is going to be on the top, whereas the 60-degree angle is going to be on the bottom since it's on the other side. That's an 1 3/4 piece thick of metal, thick piece of metal. That's a pretty big piece of metal, okay? If you have a chance to look at this chart, that's a good reference. I also have a few other references for the ag teachers in the notes. And I would say at this point, you should have a weld symbol worksheet number 2, where you're supposed to sketch some welds and have a key posted in there for the instructors as well. So work through that. I hope that this has been good information for you. And again, I can't stress enough, you need to know how weld symbols work in order to be able to speak the language of the industry. That's, to me, is a really important thing that we want to be able to do. So appreciate you putting up with me, and I'm going to stop right now and hope that you got some good out of this video, recorded video.